Now we're moving on to weirder examples. Example 5 is find the domain of g of x where g of x is equal to square root of x squared minus 1. We're going to use the same tactic that we did in the last several examples, but there's going to be a weird little twist in the middle that has to do with properties of inequalities here. So this is going to be an example where inequalities don't work exactly the same way as equalities. Okay, so we're looking for the set of all x values that I can plug into this function safely without getting division by 0 or square roots of negative numbers. Since I have no chance for division by 0 because there are no fractions in this, the only thing I have to worry about is square roots of negative numbers. So looking at this, I want to figure out all the things that make this inside of the radical non-negative. I want to make sure that they are 0 or greater. So what I do is I write x squared minus 1 is greater than or equal to 0. Okay? I want to figure out what x can be in this case. Okay? So how do I do this? Solve using algebra. So add 1 to both sides. So this gives me x squared is greater than or equal to 1. Okay, now here's the weird thing that's about to happen here. In order for me to get x by itself, I need to take the square root of both sides. But what happens when I do that is that if I take square root of this guy and square root of this guy, I get absolute value of x, because x squared square rooted is absolute value of x. Okay? That's by definition what absolute value actually is. Okay? And this implies, well, square root of 1 is just 1. So the absolute value of x is greater than or equal to 1. So that means if I plug in, say, minus 2 into this absolute value, is that greater than or equal to 1? The answer is yes, because absolute value of 2 or minus 2, in this case, is going to be just 2. All right, so I'm looking at weird cases here. You can try plugging in a variety of negative numbers here. I can plug in minus 1, and absolute value of minus 1 is going to be greater than or equal to 1, because absolute value of minus 1 is just 1. Okay? So thinking about this, what does this actually mean? When you have an absolute value that is greater than or equal to something else, or you have an absolute value of a variable, what this means is that x has to be either greater than or equal to positive version, or x has to be less than or equal to the negative version of this thing. Okay? So, as I mentioned before, I can plug in minus 2 because when I take absolute values, that's going to be greater than or equal to 1. So here, that's where this case comes into play. I can plug in minus 2 because that's less than or equal to minus 1. Okay? So this is going to be my domain. I can plug in any x value that is greater than or equal to 1, or x is less than or equal to minus 1. Okay? So what does that imply about the domain? The domain of G is precisely this, but we need to put this in interval notation. So we start with the low end first. X can be less than or equal to minus 1. So that means we go from minus infinity up to and including 1. Okay? Because I have the equal sign, I can include minus 1 here. Sorry. And then we have the second case here where we have x is greater than or equal to positive 1. So I pick up there. And I can plug in 1 because I have equality there, that little equals bar underneath the inequality. And that goes to infinity. Nothing in between minus 1 and 1 can be plugged in. You can try it, but you'll find out very quickly that if I try to plug in 0, you'll get square roots of negative numbers. So the only things that we can plug in are x values that live either in here or in here. You can plug in 2, you can plug in minus 5, you can plug in minus 300,000, because they all live in one of these two guys. Okay? So this is the domain of our function g. All right, so with that, this example is done, and we'll move on to slightly harder examples momentarily. See you in the next one.